Hi everyone. So today we're gonna be doing trigonometric differential equations. So we're gonna be doing trigonometric differential equation. If you do need more videos, please follow us on YouTube or Instagram, Twitter, and Facebook. Okay, let's go to our first example. So our first example is y equals to 2 sine x. So the first thing that you do when you come across such questions, you identify your f of x first. So this is your f of x in this case. So after identifying that f of x, you write it down. You say your f of x in this case is given by x. So after doing that, you're gonna have to find the f prime of that x there. So the f prime of x, sometimes they say d over dx of x. So it's the differentiation of x, of that f of x. So the differentiation of that, you get 1 when you differentiate this. Okay, and then to differentiate this is the formula that you use, x to the power n. If you want to differentiate this, it's x to the power n multiplied by x to the power n minus 1. This is the formula that you use. It's a standard formula for differentiation. Then after finding your f prime, the next step, you have to put that f prime back to the formula. So the formula for differentiation of sine x is here. I wrote the formula on the top right corner here. This is the formula for differentiating sine x. Okay, you can find this formula in your formula sheet. Then the next thing that you must do is to say y equals to 2. 2 is a constant. You write sine f of x there. So the differentiation of this, you're going to treat 2 as a constant. So you're going to write 2. Then you say the differentiation of sine f of x. You're going to get cos f of x multiplied by d over dx of your f of x. And then d over dx of your f of x, we got 1. So let's substitute those values. Your d over dx will be equals to 2 cos your f of x. We're going to put x multiplied by your d over dx for that f of x. So it's your f prime there. So it's 1. So your final answer will be 2 cos x. Okay, that's your final answer. If you have any question, please, I'll leave my WhatsApp number. Please text me or you can comment on the section below. Okay, let's move to the next example. So the next example, you have got y equals to cos x squared. So you're required to find dy over dx. So that's your first derivative. Okay, that's the next thing that you do. You do what you did on the previous video. You identify your f of x. So in this case, our f of x is equals to x squared. Then you have to identify the f prime of that, or find the f prime of that. And then f prime of that, let's just write d over d x of x squared. And then for this, you're going to apply the same formula. So in this case, your n is 2. So your n is 2. So it's more like it's x to the power 2. Then the formula that you use is n x to the power n minus 1. It's the first formula in your derivative table. So our answer will be 2x. Our f prime of that will be 2x. So you go back and substitute those values in your formula. So in this case, your constant is 1. So you've got 1 here. So you don't have to write that 1. Remember the previous example, we had 2 instead of 1. So you write that constant there. So in this case, you're not going to write anything because it's 1. So you write your f of x there. Then when you differentiate this, when you say dy over dx of this, differentiation of cos, go to your derivative table. If you don't have a derivative table, guys, you can search on the internet or you can DM me, then I'll send you the derivative table, or I can leave the link for that derivative table. Okay, so if you differentiate cos f of x, you're gonna get sine. Here's the formula on the top right. You're gonna get negative sine x. So you're gonna get negative sine, I write f of x. You multiply it with, always guys, you have to multiply by the f prime of that. You have to multiply by the f prime of your f of x. Okay, then your answer will be, let's substitute those values. It's minus 2x. It's your f prime. So this, it's what, it's your f prime, or your d over dx. And then you're gonna multiply it with sine f of x, which is sine x squared. And then that's your final answer there. So your final answer is this: 2x minus 2x times sine x squared minus 2x times sine x squared. That's our final answer. Then let's proceed to our next example. So our next example, you do the same thing. Remember, in this case, your f of x will be this. Remember, you cannot have tan. You cannot say tan multiplied by 4x squared plus 3x. No, cannot be this. So always, for trigonometric functions, you must have a function inside. So if it's tan, you must have x or something inside the bracket there. Okay, don't make that mistake and multiply the two. No, it's one thing. So let's identify our f of x. So in this case, our f of x is this. So you're gonna write it down. You're gonna say your f of x will be equals to 4x squared plus 3x. Then we have to find the f prime, or rather the d over dx of your f of x. Then the formula that you're gonna use that formula, the very same formula that we're using for standard differentiation. So this will give you nx to the power n minus 1. Okay. Then obviously, don't forget to multiply by the d over dx. Only focusing on this one. Okay. Then your answer for this one will be 8x plus 3. That's your f prime of x. Okay. Then you go back to the formula. You're going to say y equals to tan f of x. Then your dy over dx. You go to your derivative table. If you go to your derivative table, you go and look for the derivative of tan. So if you look for derivative of tan, you'll get sec squared f of x multiplied by your d over dx of your f of x. Then your final answer will be your dy over dx of this will be, so you write your f prime there. Your f prime is 8x plus 3. This is your f prime, or rather your d over dx. You write it there. Then you multiply it with sec squared your f of x, which is 4x squared plus 3x. This is your final answer. So your final answer is this one. Let's write answer there. That's your final answer. No need for you to expand it. You can leave it as it is. Okay. Let's do another example. So in this case, you are required to find dy over dx, which is your first derivative for y equals to tan sine squared x. So you see, identify your f of x. Your f of x is this one. Okay, let's write that f of x down. Or f of x equals to sine squared x. This, guys, can be written as sine x all squared. So you have to change it and put it that way. So once you write it this way, this 2 will be your n. This one will be your f of x for this for this problem. So remember, you're solving this one separately. So since you've got this, you can use the formula for x to the power n, where x is sine x. This x is equivalent to sine x. Then you've got 2 there, which is your n. The n, this n is equivalent to this 2. Okay, then you're going to apply this formula, n x to the power n minus 1. If you apply that formula there, remember I said you have to multiply it with d over dx of your f of x. Remember, we're only focusing on sine squared x. So we are leaving out tan now. We are focusing on the f of x for now. So to solve that, you're going to have to use this formula, the standard formula, nx to the power n minus 1. So now you're going to get 2 into sine x. So your 2 minus 1 multiplied by your d over dx of sine x. Remember, in this case, your f of x was sine x. So the f prime of that will give you, so the d over dx of our f of x gave us cos x. Because if you differentiate your f of x, in this case, your f of x was sine x. So if you differentiate that sine x, it will give you cos x. So our d over dx of our f of x was cos. Okay, let's proceed. So I'm saying our d over dx of our f of x is equals to cos x, because d over dx of sine x is equals to cos x. Remember, where there's f of x, you're gonna have to put sine in this case. So when you put it back to the original formula, you'll get dy over dx equals to minus 2 sine x multiplied by your d over dx of f of x, which gives you um, d over dx, which gives you minus 2 sine x multiplied by cos x. And then this is a double angle. You can write it as 2 sine 2x if you want to. This, guys, remember the whole point of doing this? This was your f prime. Don't forget that. This was your f prime for tan, for your original formula. It was the f prime of this. It was the f prime on this equation. Don't forget, guys, don't forget. You're going to have to substitute this back to the original formula. So the whole point of doing that, the whole point of doing those workings was to find our f prime. So I'm going to substitute that f prime back to the original equation. Back to the original equation. So remember, the first thing that we did, we identified our f of x, which was sine squared x. Then we found the f prime of this as minus 2 sine x multiplied by cos x, or minus 2 sine 2x. Okay, that's what we found. Right. So let's go and substitute back to our original formula. We have got tan f of x there, multiplied by your f prime, or rather your d over dx of your f of x. Okay, so now let's substitute those values. We're gonna have to differentiate first. I'm gonna say dy over dx of tan f of x dy over dx of tan f of x. Let me remove that. I was supposed to put it on when I differentiate. So tan f of x will give you, you want the derivative of this, you'll get sec squared f of x. Okay, multiply by your d over dx now. That's where you should put it. Or your f prime of x. So your dy over dx will give you sec squared, your f of x is sine squared x, multiplied by the f prime. So the f prime, you've got minus 2 sine x cos x. That's your f prime there. And then this should be your final answer. That's how you get your final answer. So your final answer is this one right here, where I highlighted in green. This is your final answer. No need for you to expand it. You can leave it this way. No need. Okay, we're gonna go to our next example. So the next example, you are given y equals to 3 cos ln x squared. You do the same, identify your f of x. So in this case, your f of x is this one. So you're gonna write it down. You've got ln x squared. Then the f prime of this, you go to a derivative table, you'll see something like this, ln x. But in this case, you have got ln x squared. So the f prime of this, if you want to find the derivative of this, you should get 1 over f of x multiplied by the f prime of this. So the f prime of this, you've got 1 over x squared multiplied by the f prime of that. The f prime of that, you'll get 2x there. Then this is your d over, let's just write d over dx there. This is your d over dx of your f of x. D over dx of your f of x. Then you go back to the original formula. You say y equals to 3. 3, that 3 is a constant, cos f of x. And then when you differentiate, you're going to say 3. What is the differentiation of cos? You're going to go and look for differentiation of cos. You'll get negative sine f of x multiplied by f prime. You multiply by f prime, okay? Let's write our final answer. Our dy over dx will be given as minus 3 sine f of x multiplied by your d over dx of your f of x. Okay, dy over dx will be minus 3 sine your f of x was ln of x squared. Then you multiply it with your d over dx of that. So our d over dx of that is this one. It's d over dx. D over dx will be 2x over x squared. 2x over x squared. This you can simplify it further because you're dividing the parts of the same base. So this will be, this part right here will give you 2 over x if you solve it. So let's write it on the final answer. It's minus 3 open bracket 2 over x sine ln x squared. Then obviously you're gonna have to multiply that minus 3 and 2. So you're gonna get minus 6 over x sine ln x squared. Then this will be your final answer. This is your answer. That's your answer. Okay, let's see if you have more examples. Okay, here's our next example. Our next example, you are required to find dy over dx, where you are given y equals to sec sine x. So you do the same thing that we've been doing on the previous examples. You identify your f of x. So your f of x is sec sine x. Let's write it down. Sine x. Then you find the d over dx of that f of x. You differentiate that. So the differentiation of sine x, you get cos x. Okay. After doing this, you go and write it back to the original formula. It's sec f of x. Then you differentiate now. So the differentiation of sec, you'll get sec f of x times tan f of x. And then always you multiply it with d over dx of your f of x. For every formula, guys, when you differentiate, you have to, after identifying your f of x, you have to multiply by the d over dx of f of x. Always. So this answer, it's for differentiation of sec f of x. That answer. Always you have to multiply by d over dx of that f of x. Okay, let's go. So your dy over dx, you can have to substitute those values. It's sec, what is your f of x? Your f of x was sine x, multiply by tan sine x. Then your d over dx of that f of x was cos x. Then this is your final answer. You can leave it as it is. No need for you to solve it further. This is your final answer. Okay, that was our last example, guys. That was our last example. If you've got any query, any question, please don't hesitate to text me on WhatsApp. Then if you do want to join our online sessions, please DM me for any of the modules that we offer. We offer Maths 1 up till Maths 3, and then Engineering Mechanics, AMC or EME 1501. And then also we do offer College Mathematics. If you've got any question, please comment on the section below, or you can text me on WhatsApp or leave my WhatsApp link there. Thank you for watching.